The next thing that we have is your dynamic path. Any idea what is this? Now, one more thing before I jump to dynamic path. I mean, when you go with static NAT and if you see show xlate, the translation will be always there in the table, though the traffic is there initiated or not, because it is a static NAT, right? So translation will always be there in the table. So now try to answer me, what is dynamic path? Basically, it is translating many private IP address to one public IP address, keeping port numbers in the traffic flow uniquely. Okay. Generally, this is the method what industry likes to use, rather going with costlier solutions of dynamic NAT or static NAT. Generally, we'll be going dynamic path to allow. So this is used generally to allow the internal networks to reach to internet. It's a cost-effective solution. Now, if you think about the flows, I mean, how the traffic would generate it and all those stuff. So say there is a public IP which you have purchased. Either you can use the interface IP for NATing, or you can buy a separate public IP and use that IP address for NATing. Either or, right? So either you purchase one IP from that, or you are doing an interface. So let's say what is happening here is, say there is a user, I mean, say 10.11.11.50, right? He wants to reach 200.1.1.1, and this is a TCP transaction. So the source port number, say it is 4141, and the destination port number, say it is 80. This user is trying to browse internet. Okay. When this traffic goes to the firewall, and where you applied this dynamic path, and you are patting all this network, let us say, on this public interface IP, which is 192.1.20.10. So all the users, these users, when they try to reach outside, they will be, patted on this particular IP. So what they do is, I mean, it will keep something called as an xlate table, right? In the xlate table, it will keep the entry like that 10.11.11.50 will be translated to what? To 192.1.20.10. It is trying to go to where? 200.1.1.1. But in this case, the port numbers that you see here, the port numbers is the key to make the flow unique. So say right now, this is the only first guy of this network. It is trying to reach internet, right, with this port number 4141, destination port number 80. And this is the first time the ASA is sending the traffic towards the internet. So in that case, what happens is, since it is the first user and there is no clash with any other user, it will give the same port number in the translation table. Right, in the translation table, it will keep this entry. Right, and also it will create a connection table, by the way, which will allow the traffic from where? From 200.111. The traffic is allowed to return back to the original IP, which is 10.11.11.50. When the traffic enters the public IP, so traffic will enter from where? From 200.111. The traffic will come and try to enter the public IP, which is 192.1.20.10, right? And on the port number So traffic will come from source port number 80, destination port number 4141. Now port number will be taken into consideration now. When the traffic enters, the ASA, first thing it looks for the NAT. In the NAT it sees that, hey, there is a match, because I see that, the traffic is entering to 192.120.10 on port number 4141, right? So basically I see that, I have done the translation for this guy. So basically you do translation for the source IP and the source port number in case of dynamic PAT. Okay, these two entries you normally translate. So now what will happen is you will do the retranslation back or untranslation back. So now this packet will look like 200.1.1.1 is trying to talk back to the 10.11.11.50, and you will retranslate this IP back. Source port number is 80, destination port number will be 4141 itself. And then you will check for the connection table. Connection table says, yeah, there is an entry. And if there is an entry, you do not need ACL, you do not check for the security level, traffic will be allowed to return back. Now think on a quick note, think that there is another user. Okay, there is another user which is trying to reach internet as well, which is say 10.11.11.51. He is trying to reach, say, somebody 199.1.1.1 in public. And now he comes with a different source port number, say 9190, but again HTTP, say 80. So now what will happen in the translation table? There will be another entry made up over here, right? So 10.11.11.51. Even he will translate the same IP, 192.1.20.10, same IP, which will try to go to 199.1.1.1, and since this port number is also unique, so you will keep the same port number mapped with it. So you will say that if I get a packet on port number 9190 on this particular IP address, that means I'll give the packet to 10.11.11.51. All right, but there can be a chance where there can be a third user, say 10.11.11.52. He is trying to reach, let us say, some destination IP 111.9.9.1, but he comes with the same port number like the first one. Possible, because it's a different user and tries to reach this. So in this case there will be a clash, because 4141 is mapped to 10.11.11.50, right? And now 4141 is coming from a different guy, which will be already a clash. Now in this case what will happen is the third user will also be translated, but for the third user you will keep what? You will translate the port number as well. So we'll translate 10.11.11.52 to the same IP, which is 192.1.20.10. It is trying to go to 200.1.1.1. That's fine. This got translated. The source IP got translated, and now the port number, which is 4141, it will be translated to a new one. So this port number, since it is already there in the entry, it's not a unique one, so we'll translate to something else. So which is say 9696 going to 80. And there will be mapping that 9696 is equal to 4141 for this particular translation 1, and this translation was there for 10.11.11.52. All right, so the whole idea is if I find that there are 2 or 3 users that are coming with the same source port number, only in that case I will translate their port numbers to a unique one, and I'll keep a mapping for that. Okay, so from outside if the traffic is entering on port number 9696, that means I will give it to whom? I'll give it to 10.11.11.52. If from outside there is a traffic coming on port number 4141, then I will give it to 10.11.11.50. So the whole idea is you are playing the game of the translation. You keep the uniqueness of the translation based on what? Based on the port numbers. Clear with this? Okay, so let's go for a task quickly and tell you. So basically I'm going to configure dynamic path so that the inside network, which is say 10 dot, I think I have got 10 10 10 network, 24 will be allowed to use the interface IP address of outside port ASA. Okay, so how do you do that? Similar stuff. Solution, object network, you just say like that, whatever, inside at something like that, meaningful name, and then you define the host. So basically here there are two ways. There are two ways that you can actually define it. You can create object network and define a public IP over here, okay, which is not the outside IP. So if it is, let us you purchase one public IP, say 192.1.20.155, this IP address you purchase for doing patting, you can keep like that with an object network. And then what you can do is you can call this with your pat process. So object network, then you can say whatever. I'm doing inside net for 10.10.10.0. This is my name, okay, just to make it unique. This is my name, and then I say the subnet, which is 10.10.10.0. Then the mask is this, and then I say NAT. Look here, so this is again high-low concept. So this is NAT, which is inside, comma outside, and this I will map it to the keyword called as dynamic, and then I'll write down the name, which is inside path. Right, this is one thing. So basically you are doing path for all the 1010 series subnet on this inside path IP address. There is other method, other way is doing path on the interface. In that case, you should not call the object for the public IP. So basically what you do is this, you say object network, and then you just define a meaningful name, say NAT 10.10.10.0, that's my name over here. All right, and then you can say subnet, which is 10.10.10.0 to 55.255.255.0, and then you can say NAT inside, outside, and then you can just give the keyword as dynamic with the keyword as interface. Now when you give the keyword as interface, it will choose this outside interface automatically, because this inside keyword corresponds to the inside subnet, this outside keyword corresponds to the outside interface. So whatever interface you write on this section, it will correspond on this interface section. So if you write here DMZ, it will correspond to DMZ. If you write here outside, it will correspond to outside. Okay, so generally you will be doing this, but I've shown you that there are a couple of ways to do that. If you buy a public IP and pat onto it, this is the way. If you want to use it on the interface, this is the way. All right, call the subnet, call the interface path. Here we go. Done. ACL and not is not the concern over here. If you need ACL, you can apply it later if the traffic is initiated from outside to inside. Otherwise, generally in this case, your 10.10.10.10 network will try to reach outside, and it is high to low traffic, so TCP/UDP packets will be allowed. So now what I can do is I can go to R1, and from R1 I can say telnet to 199.111, but not like that, but with a source interface of loopback 1. So generally loopback 1 is my 10.10.10 IP. So you can see that, not typing the command, you can see show IP interface brief. So loopback 1 is basically my 10.10.10 IP. So this IP is trying to access outside, and I will pat it. So going further, moving this, telnet, and I can access inside R2 and say show users, and you can see you got the patted IP address when the transaction was, or the flow was taking place. And now when you look for the NAT over here, when you say show NAT detail, you'll have here, a transmission that took place for the dynamic part over here. You have done this, right? And this is the NAT detail stuff. And if you see show xlate, you'll see that there is a TCP path, which is from this going to this, right? And you can see what is the port numbers. So by default, this is the first drive which went out. So the port number is unique, and the port number is not translated because there is no other clash with any other port number. So if I have got 10, 10, 10, 2 going with the same source port number, like 10, 10, 10, 1, in that case, it will be a clash, and I should actually translate that to a unique value for my second flow. Otherwise, it is not required. All right, and likewise, if you see show con, there will be a connection table which is allowing the IP address from 199 to 10.10.10.1 on this particular port. All right, this is the way it works. And the last thing that we have for the day is gonna be static path. Static path. Now, do you understand where I'll use this? Think about it. Where I'll use it. It is used to represent DMZ servers private IP address was single public IP address, but many DMZ servers private IP address to a single public IP address, but keeping unique with port numbers. We'll see this in action. For example, let's say what happens now. So if you have here, let us say some 2 DMZ servers, okay, which is say 3.20, this is say 3.30, and you want to represent them outside, but you don't have enough, public IP. So in static NAT, the problem is individual servers should have an individual public IP, but in case of static path, you try to solve that problem. So you can have hundreds of servers which could be mapped to one public IP. Okay, how do they do that? So let's say I've got a couple of servers over here. I'll map them to a single IP address. So say I'm mapping that to a public IP. Say it is 192.1.20. Say 179. Okay, that's my unique public IP which I'll map. Now say this is my web server, and so this is my DNS server. Think about it. So say people wants to access my web server. So source IP could be anything. Destination IP would be the public IP, right? And since they are trying to access my web server, so source port number, say it is random, destination port number it is 80. When the traffic comes to my ASA, I have done the NAT over here, and I've told in the NAT, I've told in the NAT this, that 192.120.179, it is known to, or it is mapped with 192.168.3.20 for port number 80. Right, in static pat, sorry, it is static pat. So in static pat, I have told this, that this IP address on the public, it is mapped to this private IP on port number 80. Now also I have to configure the same IP, which is 192.1.20.179. The same IP address, it is mapped to 192.168.3.30, the other server on port number 53. So now what happens is, if I receive a traffic from anybody on the world of internet to this public IP address on port number 80, I know what I should do. That means I should give the traffic to whom? Untranslate it and give the traffic to whom? 3.20. But ensure that I should have an access control list, because the traffic is coming from outside and trying to reach my DMZ. So I should have an ACL that will also allow this traffic to come in. Okay. Now similarly, when anybody wants to access the same IP address 192.1.20.179 with whatever port, doesn't matter. Okay. But on port number 53, I know that if I get any IP address that is coming on this IP, destination IP is 179, but on port number 53, I know in my NAT what I have done. So port 53, the traffic should go to 3.30. That means the traffic should go to this particular server, ensuring there is an ACL that allows the traffic to come back in. Okay. So now there could be a condition where you want to secure your web servers or DNS servers. So basically the whole people, the entire world knows that web server runs on port number 80 and the DNS server runs on port number 53. The whole world knows about it, right? But you want people to reach your web server, but not on the common port. You want to allow people to reach your web server, but on a different port. That means you want people to access the web server, not on port number 80, but on port number what? Say 8089, right? That means in your transition table, it will be like that. That means if somebody is trying to come on this IP address on port number 8089, you will do, you will actually do port forwarding on port number 80, right? So similarly, if you want to safeguard your DNS port number publicly, so say you tell that, hey, you come on 5351. So if somebody is trying to reach on this public IP on 5351, this is actually mapped to the original servers on port number 53. Okay, so this is also called as port forwarding, and you can do that. But that's the concept of static pat. So you can keep multiple servers hosted outside, and people can access your multiple servers on the public IP address. Okay, and you can keep the uniqueness on the port numbers. So syntax that we normally have is object network, then you define a name. It's very similar to static pat. So normally you will be using the host IP. So basically you'll be using the hi IP, which is basically your DMZ server's IP. And then you say NAT, then you say hi interface name, then you say low interface name, use the command static, then you can define the low IP, right? You can define the port numbers with a keyword called as service, either TCP or UDP port numbers you can define here. All right, and then you can define the high port number, right, followed by the low port number. That's your syntax for your static pat. So now if I want to represent the same task, what I'll do is I'll copy the task from your static NAT. I'll just represent it for DMZ4 now. So I'll just copy the entire thing, and also I'll copy the ACL, so it becomes easy for me to do that. Okay. So what I'm doing is I'm representing the web server of my DMZ 4. So in that case, it is say 4.20, 4.30, and I have got 4.4 as my DMZ 4. So instead of R3, this is R4. So I'm representing my DMZ 4 servers outside now, and this is having a unique IP. I mean, now it will be all unique IP. Say it is 20.175 as a unique IP. Every servers represent with this IP, right? Just say it is on TCP port number 80. So this is your this, and say I'm going to allow only Telnet and ICMP. Okay. So now going with your solution. So how would I do that? Object endpoint web server. What is my host over here? It is 3.20. Now it is actually 4.20. So I'm doing that. This is going to be high interface is DMZ4, low is outside. I'm doing static, and I'm representing this to 20.175. Okay, 20.175, and I'm using the service keyword to define the port. Now, which port it is? HTTP, so it works on TCP. Now, see the syntax: high port number, low port number. High port number means the real port number. So, real port number is 80. And if you want people to come on this web server on port number 80, then give the port number 80 on the low side as well. All right. If you want it to come on port number 8080, you define it here. So people from outside will come on port number 8080 in order to reach your, web server. Okay. But I want to make it say 80. So keep it like that. But similarly for email server, this is, 4.30. So this is web server for DMZ4, just to keep things unique in the names as well. DMZ4, and this is gonna be DMZ4 outside static. It's gonna be same 175. This is gonna be service on TCP, and this is gonna be 25 high, 25 low. And likewise for R3. Now this is not R3, this is actually R4. This is for DMZ4. This is going to be 4.4. I'm going with DMZ4 outside static. This is 175. Now say service, you want to verify using, say I want to verify only, keep things simple, say I want to verify using only Telnet. So service, let's say it is 23 as a real port number, but I want people to come on port number 2323, okay, for fun. So if people want to access my R4 using Telnet, they'll access on port number 2323. Okay, access list, you need to allow TCP traffic, which is basically the real ones. So this will be 4.20, and I don't have port number HTTPS, so I can omit this ACL. SMTP is basically your 4.30. Okay, and I'm allowing only Telnet. Now Telnet, I will actually allow the real port number. I don't have SSH, so removing this. I don't have ICMP, so even I can remove this. And Telnet is basically my 4.4, but make sure that I will allow on the original port number when you write the ACL. And already my ACL is applied on the outside interface with the same name. That's not a problem. Is that clear to everybody? Yes, no?
Yes.
Very good. So ACL is already applied. I just copy this 3 ACL first and go to my firewall. Go, do that. Done with this. And next you go to the static path configurations. Copied it. Okay, save. Oh, I think nobody has reminded me regarding that. You could have reminded me, guys, because 175 is there with the dynamic NAT, right? So what I can do is right now, I can just remove the dynamic NAT for time being. Because we're already done with the days class. If you see show run, object, I've got dynamic NAT, which is my pool, that is linked to your inside network. So first of all, I should actually remove this node to your object network. And then I can remove this my pool. There we go. So now if you see show NAT detail, you don't have dynamic NAT created now. You have DMZ3 to outside. You have got DMZ4 to outside. Now it is taken. Web server is taken. Inside to outside, this is taken, that's fine. But I don't see that entry for my router, which is this one. Copied it. What is the mistake, guys? I have not written what? TC.AQ, TCP. So let me with the existing pool. Which one? I don't have any pool. Pool has been deleted. Oh, sorry. TCP. Yep, I took now. If you see show NAT detail, you should see the router is getting translated. So, yep, this is R4 DMZ. I'm translating it to the original IP is .4, translated to 175 on port number 2323. So if from outside I want to telnet my R4, I will not telnet on port number 23, I'll telnet on port number 2323. Here's the game. So now what I do is look into that. I go to R2. From R2, I want to telnet 192.168.1.20.175. But with normal telnet, I will never reach because my mapping is based on port number 2323 in my NAT table. So it is based on 2323, not based on 23. All right. So similarly, if I go to R2, it will not happen. And if you want to telnet it on port number 2323, here we go. You are inside R4. Show users you come from the public. I hope it's clear and understandable by everybody. So we're done with the important 4 types of NAT, couple of NAT, destination NAT and policy NAT. We will do it in the next class along with transparent firewall. Okay, so looking forward for the next class, which is I think on Wednesday.
Yes.
All right. Any question? All well? Done until here. Okay, so thank you all. I'll talk to you guys on next class.